Welcome back to today's class, children. In our previous class, we derived the equation for acceleration due to gravity, that is g. So g is equal to gm by r square. Children, we know that our earth is not a perfect sphere. Earth is not a perfect sphere. So the radius of the earth increases from the poles to the equator. So the value of g becomes greater at the poles than at the equator, since our earth is not a perfect sphere. So g is more or less constant. We consider g as constant when the object is near or on the surface of the earth. But when the object is far away from the earth, the acceleration due to gravity is given by the value. So what is that value? Let us see now. So we know the equation for g is equal to gm by r square. So the value of g, that is universal gravitation constant capital G, is 6.7 into 10 power minus 11 Newton meter square kg power minus 2. M, capital M, that is the mass of the earth, that is 6 into 10 power 24 kg. The radius of the earth is 6.4 into 10 power 6 meters. Now we need to substitute all these values in this equation. So when you substitute all these values in the equation, we get the value of g as 9.8 meter per second square. Okay, or meter s power minus 2. So this is the value of the g when the object is far away from the surface of the earth. Okay, children. So now let us move on to the next one, that is motion of objects under the influence of gravitational force. So we know that earth attracts objects towards it. So here there is an activity which is given to you where you are taking a paper and a stone. So paper and stone both are dropped simultaneously from a height. So what can you observe, children? We observe that the paper reaches little after the stone due to air resistance. So the paper will be reaching later than the stone because the air resistance will be more on the paper than that of a stone. So air offers resistance due to the friction to the motion of the falling objects. So why is air offering resistance? Because of friction to the motion, that is movement of the falling objects, the objects which are falling down. So that is why the paper will reach little later than that of a stone. But if we do this experiment, that is dropping the stone and the paper in a glass jar from which air has been sucked out, in the sense when the air is removed from the glass jar and this experiment is done in that condition, then the paper and the stone would fall at the same time. They reach the ground at the same time. So this was observed by the scientist Galileo, that is the Leaning Tower of Pisa, and he has just thrown the objects, different objects he has thrown from the Leaning Tower of Pisa. Okay, so we know that all the objects which are falling down, they involve acceleration. So the object experiences acceleration during the free fall. So hence acceleration is independent of its mass. So acceleration is independent of its mass, whether the object is hollow or it is a solid or big or small or should fall, whichever is falling down, they have to reach the ground at the same time. Okay, children. So here this acceleration is nothing but due to the gravitational force, acceleration due to gravity. So this will be possible for all the three equations of motion, that is it holds good for all the three equations of motion. So what are those three equations, children? V is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. So all the three equations of motion will be coming under, will have this acceleration due to gravity also. It holds good for all the three equations of motion. Okay, and here A is taken as positive when the object is moving in the same direction of towards the earth, that is in the direction of motion. Okay, the acceleration is in the direction of motion, then it is taken as positive. If it is in the opposite direction, the A will be taken as negative. Okay children, so you read the textbook so that you can understand it very clearly. We'll discuss about all this in our interactive class. Thank you children. Have a wonderful day.